All right, move on. So now we go to virtual LANs. But before I go to virtual LAN, I want to make sure that you all understand what is a LAN. Okay, so the definition is not by the distance, not by 2 kilometers, not by 5 kilometers, not by 200 meters. The name local is misleading. A LAN is a single broadcast domain. That's the definition of a LAN. If I can hear your broadcast, we are in the same LAN, period. I could be in Germany, but if I can hear your layer 2, we are talking layer 2 broadcast. If I can hear your layer 2 broadcast, we are in the same layer 2 domain, layer 2 LAN. We are layer 2 network, which is a LAN. And in the IP terminology, we call it a subnet because the Ethernet broadcast cannot cross the subnet. A router will not pass anything which is not addressed to a unicast something. So therefore, in the IP world, it is a single subnet. And so there is no, when you talk to other members in the same LAN, you basically don't need routers. Right? You can just send an Ethernet packet and it will be picked up by the other guy or forwarded by the bridge all the way to the other guy. And so you are much faster. Going through router is kind of complex. So, but if you go to other LAN, then you need the IP, you need the IP address, you need the router, and so on and so forth between the two LANs. So here you have a LAN 1, you have a LAN 2, you need a route. You have a router, that means this people will broadcast, but these people will not hear those broadcasts. Right? Here, these two people are on the same LAN because they are connected by a bridge. When somebody broadcasts here, they will be here. Broadcasts are forwarded by the bridge. What does bridge does not forward? There is something that bridge does not forward. There was another domain we had talked about in the last class. Hubs. What kind of domain they make? So the bridges don't forward a half packet or incomplete frame or anything like that. Alright? But hubs do. They don't wait. Hubs don't wait for the end of the frame. They just start sending the first bit in, first bit out. And so they can cause collisions, but in the bridges on one side and the people on the other side, they don't collide. So people can speak here happily on this thing and they can speak happily on this thing at the same time. They will not collide because only the full frames will be forwarded. But they can still have basically, but still this is one domain because it is broadcast domain. The broadcast packets will be fully sent from here to there. So there is one broadcast domain. By the way, you got to keep reading every day when I give you the reading assignment. So this was in the previous reading assignment. I think it was maybe, or maybe not, I don't remember. But this whole thing about the bridges and the switches and routers and hubs we discussed in the last class, and I have a reading list at the end. Maybe it is in this same module. But you got to keep up because we are going to use it one by one, and that's why the slides are in that order. Because once I tell you something, I need to use it next. So anyway, so a LAN is a single broadcast domain. Agreed? So far? Okay. So what if we have three departments: marketing, engineering, and manufacturing? Obviously, marketing does not want engineering to see its data. Manufacturing does not want. Actually, marketing, engineering, and manufacturing are not that don't have that enmity. But if it was finance, they don't want anybody to see their packets. Finance people in any company are very, very, closed department. You don't know what is your president's salary, and they don't want you to see that either. All right. So the finance. So how do these people do? They have to have a separate network. Well, even if they have a separate network, what if the finance guy moved from second floor to the first floor? Because if there was not an office left there, now we need a separate network from the first floor. So the idea is a company will have one network, but somehow we have to carve out virtual networks out of this one physical network. So we will have, in this case, we have this network and we want to carve out three different networks: marketing LAN, engineering LAN, and manufacturing LAN. Okay, if you ever want to cross from one LAN to the other, you have to go through the router. You cannot directly broadcast or go or see or anything like that from other LANs, even though you are on the same fiber, same copper wire, same switches. So we need to do that. That is a virtual LAN. So basically, you can think of this. You can, in your company, you have many different colors of the hosts, not the bridges. The hosts are different colors, and all the hosts of one color are on one LAN. All the hosts of different color are on different LAN. So basically, you have this engineering department, which is red color, finance department is blue, and so on and so forth. So when you come in, you sign up your sign-up paper and say where you are signing up finance department. Your computer is put into the database as you belong to the red host, red LAN, red VLAN to be exact. All right. Now your computer will see only red broadcast packets. It will not see blue and green. So they went through several processes, and finally, basically, so all of this is history actually. First they thought that layer 1 would be the right thing, that each port will be declared as a LAN, as a VLAN. So for example, we could say the port A1 is in VLAN 1, port A2 is in VLAN 2, port A3 is in VLAN 1, port B1. So here's the thing. You have these switches, and we could just go port by port, and these are the end hosts, by the way. So these ports, we could say this is marketing, this is engineering, and so on and so forth. But this is too much work. Why too much work? Because somebody has to watch every day whether the marketing guy is moved or not, he's still there or not, right? It's just too much. So then they said, we will do MAC addresses. So we will note down your computer address and then write it down in a table someplace that this MAC address belongs to marketing department. And that went on for some time, but I think finally ended up with layer 3 VLANs. A layer 3 VLAN simply means that, when you go to get the IP address, when you go to the DHCP server or you static IP, whatever it is, basically whatever subnet you are in, you are given, that decides which VLAN you are in. So basically you say, well, I'm Raj Jain. Then they say, oh, you are in the educational department, something like that, as opposed to finance department. And so you get a subnet address, or you get an IP address in education subnet. In our case, we'll get a CSE subnet, and we won't be able to see any finance data, right? So basically, everybody who has this IP address, now here is where the Ethernet and the IP get mixed up in this case, is that if you don't have an IP address, you don't get a subnet, and then you don't get a VLAN, and then you can't do anything. But the idea is that is the easiest to manage for the people who are managing these networks. They can just manage it through their DHCP server through some rules. All right? But it is equally actually as good as this one here, second one, because what they're doing is in the DHCP server, they're looking at your MAC address and then giving you IP address. Right? So there is some table somewhere. Anyway, so what happens in the packets? How does the switches know who is in what LAN? So each packet now has something else in the packet. Actually we don't call it packet, by the way. We call it frame. So just to be exact, layer 2 things are frames. Layer 3 things are datagrams in IP world. Okay? And layer 4 things are something else. So every layer has a name for it. Okay? And so layer 2 is frame. In the OSI world, we would call it layer 2 PDU, protocol data unit, layer 2 protocol data unit, layer 3 protocol data unit. But in the IP world, we don't use layers actually in that sense. So basically, we have a name. Frames are for Ethernet. Datagrams are for IP. All right, so a frame, untagged frame. The original frame was like this: destination address, source address, type or length field, then the data field, and then the CRC. Now here, if the type was LLC, then you will see LLC header. And so this is the original frame. Now with 802.1q, we add 32 bits. The first 32 bit is the protocol type. So this is TPI. So this indicates what type of header is next. and this will say I have a VLAN header. So this is fixed for the VLAN type. Okay. There is a particular bit pattern which you can find in Wikipedia and other places. I didn't want to put it here because it's not relevant and you will unnecessarily kind of trying to remember what is the TPI for VLAN. So there is a TPI for VLAN. So this one says everything that follows is VLAN header. And then the real protocol type is here. So once you are finished with VLAN, then you say, what do I do with this frame? You look at the type and length field, and this says, oh, this is an IP packet. So the original type and length field is sent here. We put a new type length field, and that is VLAN. Now, so out of these 32, 16 bits are gone, right? We are left with the next 16. 3 bits are for priority. 1 bit is for CFI and DEI, and 12 bits are for VLAN ID, what VLAN number you are in. Now, what is CFI? In those days, there were something called token rings. We don't have token rings anymore, by the way. All right? In those days, there were token rings, and the token rings used a address numbering system which was slightly different than the Ethernets. The order was different. One might send out the first bit, the most significant bit first, the other might send out most least significant bit first, things like that. I don't remember exactly. So there is a canonical format which is for Ethernet standard format, which is 0. CFI is 0 means it is standard format. If it is 1 means it is token ring format, because there was a case also where you could have token ring bridged into Ethernet, because both of them are 802 frames. You might want to send them over Ethernet sometime. So CFI indicates whether this is canonical or not. Now there are no token rings, so we don't need CFI. So now it is used for DEI, drop eligibility indicator. That means this packet has a lower priority or high priority. If you get into trouble, throw this packet away. 0 means good, 1 means no good. All right, so that is 1 bit. Now we have 3 bit priority. So the priority means we have 8 priorities, 0 through 7, and 7 is high. 7 is high means if there is a trouble, 7 gets through, 0 is dropped. Of the packet, actually basically the source does. So the source wants to send a lot of traffic and then puts some 0 and some at 1 and so on and so forth, because here you think, suppose you are doing video, the video generally has E frame, I frame, not E, I, P and B frame. There are some frames which are a higher priority for you. You want to make sure that if there is a congestion, please don't throw away my I frames, throw away my B frames. So you mark them lower priority, higher priority. The network doesn't. If you are doing a backup or something, it's not very high priority, you can mark it low priority. All right, so there is a priority, 8 priorities, 0 through 7. 7 is high, 0 is low. And so that is part of this VLAN. And this is the reason I had to put this part of the lecture in this module. I really didn't want to get into virtualization at this point, but I need priorities. Since I need priorities, I needed to explain this whole 802.1q. All right, we have a whole virtualization coming up in a later lecture. So anyway, so now that we have priorities, so now we understand that we have 8 priorities in Ethernet, and they are in this VLAN tag someplace, and so every packet carries this, and when a bridge sees this packet is coming from this VLAN ID, so whether it should go here or not, whether it should go there or not, and even the broadcast packets have the VLAN ID, so it can decide whether this broadcast should go on this side or not, whether this broadcast should. All the broadcasts are sent to everybody on the LAN, right? So that means all the broadcasts are sent to everybody on that VLAN. So the marketing people's broadcast will not be seen by the finance people. In fact, marketing people's packets will not be seen by the finance people either, the unicast as well. All the packets will have VLAN ID. So now the forwarding is done on the basis of 2 things, not 1 thing. Previously, it was done basis of the destination address. All the switches did was look at the destination address. They don't look at source address. They just look at the destination address, where are you going, and they say, okay, go through that door. Now they look at 2 things. What are the 2 things? VLAN ID is first thing. If you say I am VLAN ID and I want to go to the marketing department, they say, oh, sorry, that door is closed. You go to the router. and so you cannot go to certain destination on that VLAN. Your packet will be actually dropped. I mean, you won't get any message saying that it goes to the router. It will be just dropped, and so the destination not reachable kind of message you will get. All right. So those are two things. Now, moving on. So the next protocol is LLDP. Now, Ethernet has also many options and features and so on and so forth. So they needed a protocol to manage all this automatically. So you can ask a switch, do you implement RSTP? Do you do link aggregation? Do you do VLANs? Things like that, right? So how do you do it? There is a protocol for that, and that is called LLDP, Link Layer Discovery Protocol. So it is actually what they call neighbor discovery. What that means is that you can ask your neighbors, what can you do? What are your capabilities? Right? And that is what neighbor discovery is. First of all, finding that, yeah, there is a neighbor, and then second, finding out what they can do. Right? So that we do the right thing. So this is a neighbor discovery protocol by periodic advertisements. Every minute, an LLC frame is sent on every port to neighbor. What is LLC? Yeah, logical link control. It was said in the last class. I think in the last class I talked about it, right? That 802.3 introduced logical link control. LLC frame is sent on every port to neighbors, and the LLDP frame contains information. It's just a very general frame. It can have any number of fields. Each field has a TLV. TLV means type, length, and value. So here is the LLDP frame: destination address, source address, length of the. This is actually T/L. It should be type/length. Oh, basically length, because I am showing LLC. This is an LLC frame. So basically, it will have a length field. In the LLC, it will have all that information, and which I am not shown here. But anyway, after LLC, you have TLV, 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 as many TLVs as you want. So what is type, length, and value? Everybody understands what is TLV means? Is that when you submit something, you say, well, this is information is number 13, and its length is 2 bytes, and value is 15. Now, what is number 13? Everybody knows what is number 13 because there is a standard for that as to what type 1 is, what type 2 is, what type 3 is, what type 13 is. Every value comes with a length. Now, the question is, if you knew the type, then why do you need the length? It's type 13, right? But the answer is sometimes some fields are variable length. For example, my name is only 7 characters. Your name is 25 characters. So we need to put a length field. Type, length, and value. Type is what information it is. Length is what is the length of this information, and value of this information is B, right? So TLV encoding. So basically, so there are many types which have been standardized, and there are many types which are being standardized, and every time some new protocol comes up, a new type comes up. Okay? So here's my chassis ID, my port ID, time to live, port, descriptor, who made me, what is my product name. So you could say, well, I'm Cisco 2305, whatever number that is. And so basically this is useful because the other switch can use it, or the manager can use it for that information that, this is my inventory right now, and this is the capability. And system name, capabilities, MAC address, IP address, power by MDI. What is power by MDI? First of all, what is MDI? MDI is media dependent interface. So basically, the Ethernet originally did not carry power. If you connect two devices with Ethernet, both of them have to have power. But they noticed from USB carries power. Right? So in USB devices, you don't need power. You can just connect a device and it works because it's getting power from the computer. So they said this is really good. So now Ethernet provides power. So, but not every computer or not every Ethernet interface, particularly the ones which are old, provided. New ones do, but old ones don't. And you need a lot of power in some devices, so on and so forth. So there is a whole mixture. So anyway, so that is a capability that some switches have or some ports have, power by MDI. Okay, this is actually not so prevalent today still that anybody will depend upon that. So really every device that can be powered by Ethernet also has a power port. So because it is not prevalent right now. You haven't heard about it so far, I suppose. So obviously you know. But there are cameras Particularly security cameras nowadays have to be connected everywhere, and so they can connect to the Ethernet, and then they don't need power. As long as they have Ethernet, they're done. But your switch has to have power, and it has to supply power on the Ethernet port. All right, link aggregation, maximum frame size, everything else. By the way, maximum frame size went into the drain already, because if you had a 1518 byte frame and you added 4 byte, it became 1522. You guys at the end, hello? Can you close that computer? Somehow it bothers me. I'm not sure whether you're paying attention, full attention here. So please pay attention. So anyway, so the idea is that now the question was last time in the quiz that maximum frame size 1518, that was someday. It no longer is. In fact, as we are adding more and more protocols, the length is becoming longer and longer. All right, but somewhere around 2000 or 1800 something, so the thing is, numbers are kind of variable depending upon whatever it is. But anyway, so all that has to be exchanged. We exchange what is the maximum frame size. Yeah. Okay, so if you want to connect 2 VLANs, as I said, you need a router. And I did not say this in this picture, but you see there is a router here which has only one port. Okay. The reason you need this router is because if you want to go from one VLAN to the other, you need to go to the router, and you can come back on the same port, but you are on a different VLAN now. So if that is what you mean, yeah. So there are routers that you can cross from one LAN to other LAN, or from one VLAN to another VLAN.